Yes, Sam the guy. In this video, we're going to talk about carbapenems as a class of beta-lactam antibiotics. We talked about penicillins, cephalosporins, monobactams. If you haven't watched those videos, please, the videos are there. Also, check the description for this video below. The links are there. Here is the layout of what we are going to discuss. We want to know why are they called carbapenems. We talk about the SAR, nitrocarbapenems, their properties, and drawbacks. The modifications which were made to improve the natural carbapenem. We talk about the new or the second generation carbapenems. Formulations, talk about the interactions and other carbapenems. So let's begin. Why are they called carbapenem? The difference is in their structure. When we look at the structure of penicillins, this is the structure of penicillins. This is the penicillins. For carbapenem, you have this structure. This is the general structure for carbapenems. This ring is called penem ring. Penem ring. Penem ring. And this is penem. It is called penem because you have a double bond here. This is penem ring. And they are called carbapenem because we have a carbon here instead of a sulfur group like that in penicillins. Here we have other groups where we have changes at those other groups. And for penicillins, the changes are at this other group. So they are called carbapenem because you have a carbon here and the ring has a double bond. These drugs, they inhibit the enzyme known as the transpeptidase. Transpeptidase enzyme. This enzyme is responsible for the constant leakage of the peptidoglycans. From here, we form the dipeptidoglycan. Then, this means we are synthesizing the cell wall. So, if this enzyme is inhibited, meaning that there is no cell wall synthesis, meaning we shall have the cyto action. So, these drugs are bactericidal. They are bactericidal. They inhibit transpeptidase enzyme. They have a broader spectrum of activity than even the penicillins and cephalosporins. They can target gram positives, the gram negatives, and some anaerobes. But their activity targets more of the gram negatives. So they have a broader spectrum than penicillins. That's all we can talk about the carbapenem. Let's go to the SAR. For the SAR, we have this structure here, the general structure for carbapenem. This ring, the penem ring, is the pharmacophore. This ring is the pharmacophore. With this carboxyl group. This carboxyl group increases the reactivity. It improves the reactivity of the beta-lactam ring. So it leads to the opening of this ring. Then we have this R1 group. This R1 group is responsible for the spectrum of activity. It is responsible for the penetration into the bacteria. Now we have this group here, the double bond. This double bond improves or increases the strain. When you increase the strain, meaning that we are increasing the opening of this ring. So it increases the ring opening. Hence, increases the reactivity of the carbapenem. Then we have this R2 group. This R2 group, as we are going to see, is responsible for the inhibition of the degradation by the DHP enzyme, the dehydropeptidase enzyme 1. It is DHP-1 enzyme. It's found in the kidney. So this group, R2, is responsible for the inhibition of this enzyme. We have the this hydroxy ethyl group. This one is responsible for the steric hindrance. Hence, decreasing the degradation by the carbapenemases or the beta-lactamases. Decreases the degradation by beta-lactamases. Due to its sulfur orientation, the OH group is oriented towards the ring, the beta-lactam ring, hence reducing the degradation by the beta-lactamases. So that's the general SAR for the carbapenems. We can talk about the natural carbapenems and their properties now. MK guy. For the first carbapenem is known as the thyramycin. This is its structure. This is the structure for thyramycin. That is thyramycin. It's the natural carbapenem. As other carbapenems, it has a broader spectrum of activity. Can target gram-positives, gram-negatives, and some anaerobes. Also inhibits some beta-lactamases. So it's the beta-lactamase inhibitor. Although not all, but some beta-lactamases. It was obtained from Streptomyces cattleya. This is the organism where it was obtained from, the Streptomyces cattleya. This thyramycin had some drawbacks. Some of the drawbacks. One, it is unstable in solution. Like the penicillins and cephalosporins, the alkaline and acidic solutions, it is unstable. Also, at its relatively stable pH, that's around 6 to 7, this carbapenem undergoes concentration-dependent inhibition or destruction. Concentration-dependent destruction or inactivation. It is inactivated at higher concentration at 6 to 7, which is its relatively stable pH. We are going to see this mechanism here. Also, this carbapenem is destroyed by the DHP-1, the hydropeptidase 1. This enzyme is found in the kidney. So those are some of the drawbacks for tyramycin. So they have to improve it or modify its structure such that we can get other carbapenems. For concentration 6 to 7, this is due to the intermolecular aminolysis. Intermolecular aminolysis. Inter means different. So mean that if you have that tyramycin here, this is tyramycin. At higher concentration, another molecule of the tyramycin represented by this, having this amino group here. This amino group, I've just represented this amino group here. This is the other part. Acts as a nucleophile. It will attack the beta-lactam ring, hence leading to its opening. So we shall have this. We shall have, this is now NH with this group here. We have the NH group and this other part. So the moment you open the beta-lactam ring, means that you are inactivating the drug. So this one is inactive. So at higher concentration, there is reduced potency. Potency is reduced due to intermolecular aminolysis. This amino group acts as the nucleophile, attacking the beta-lactam ring, leading to its opening, as the drug is inactivated. Now, we want to see the modifications which were made to improve this effect, and also what was done to improve this DHP-1 degradation. Yes, for the modifications or improvements which were made on tyramycin, they came up with imipenem. This is the structure of the imipenem. This is imipenem structure. We can see that we have changes, or we have a change here at this position only. This reduces the nucleophilicity of this group. Meaning that there is no intermolecular aminolysis. This problem was solved, meaning that this drug at 6 to 7 has reduced intermolecular aminolysis, hence inactivation of that drug. So this drug will be active at 6 to 7. There is no decreased activity of that drug. This group is called the formidyl group. So imipenem is also known as the formidyl tyramycin. which is formidylthyramycin because of this formidyl group. Again, this drug, we see that the only change is at this position, meaning that it's also inactivated by the DHP-1. The solution for this was to make a combination. For the imipenem, they added cystatin. This cystatin is a DHP-1 inhibitor. It inhibits the DHP-1 enzyme or the dehydropeptidase 1 enzyme. So, if the combination is administered, meaning that there is no intermolecular amino lysis at 6 to 7 and there is no degradation by DHP-1 enzyme. For cystatin, this is structure. This is cystatin structure. This is cystatin. Combination of this drug with imipenem is called premaxine. This is the combination of the cystatin plus imipenem. So that was the modification, but still we have a problem that there's no drug itself which can inhibit the DHP-1 enzyme. Now this was done for the new or the second generation carbapenems by modifying this position. This is position 1, this is 2, this is position 3, and this is position 4. At position 4, they modified them so that we can have the newer carbapenems which themselves can inhibit the DHP-1 enzyme. The half-life of this drug, the combination remained around 1 hour. This is due to the secretion by the kidney. Though we inhibit the DHP-1 enzyme responsible for the degradation of the imipenem, but because of the secretion, the half-life is still low. I think for this video, let's stop here and we see the new carbapenems in the next video and the rest of the content.